So let's finish discussing derivatives. We were discussing applications of derivatives, and now let's talk about increasing and decreasing. So find the open intervals on which the function x cubed minus 3/2 x squared is increasing or decreasing. So if you're looking for something that's talking about increasing or decreasing, it's talking about the first derivative. So find the derivative of f, your function. It's 3x squared minus 3x using the power rule. And you're going to set that equal to 0 and solve. Here my function is not undefined, so I don't have to worry about that. Just where is it 0? If you factor out a 3 and an x, you get two solutions, x equals 0 and x equals 1. And then we make a sign chart for our derivative. Here's 0, here's 1. So if I need to pick some test points in here, let's pick -1, pick 1/2, and 2, and plug them into your derivative. This is f prime of x to see if it's positive or negative. So I'm going to use this factored form right here. If I plug in -1, 3 times -1, -1 minus 1. So this part will be negative. This part will be negative. A negative times a negative will be positive. If you plug in 1/2, 3 times 1/2, 1/2 minus 1. This part is positive. This part is negative. Positive times a negative is negative. And if you plug in 2 into your derivative, 3 times 2, 2 minus 1. This part is positive. This part is positive. Positive times positive is positive. So anywhere you have a positive, it's increasing. Anywhere it's negative, it's decreasing. So where is it increasing? From negative infinity to 0, and then from 1 to infinity. And where was it decreasing? It was decreasing between 0 and 1. All right, and then let's talk about concave up and concave down. Let's look at the next example. Determine the open intervals on which the graph is concave up / down, and the function we're going to look at here is x to the 4th minus 4x cubed. Now here it's talking about concave up, concave down, which means you need the second derivative. If you're talking about concavity, that is the second derivative. So we're going to take our function and find the first derivative, 4x cubed minus 12x squared. If you were talking about increasing or decreasing, you would look at this function, but because we're talking about concave up, concave down, we need the second derivative, so you're going to take another derivative here. That's a polynomial. It's always defined. So you're going to set this equal to 0, solve, factor out a 12x that they have in common, and you get x equals 0 and x equals 2. So we're going to make a sign chart again, just like we did on the last problem. But now this sign chart is for the second derivative. So we're going to use this factored form right here. Pick some test numbers. So I'll pick -1, 1 and 3 and plug them into your second derivative. So if I plug in -1, this first part is negative, the second part is negative. Negative times negative is positive. Plug in 1. So this will be positive, this will be negative, so overall negative. And the last one, plug in 3, so 12 times 3, 3 minus 2, this is positive, this is positive, positive times positive is positive. So anywhere there's a plus, it's concave up. Anywhere there's a minus, it's concave down. So concave up from -infinity to 0, and then from 2 to infinity, and then it's concave down from 0 to 2. So if you are looking for concavity, concave up, concave down, you would want to look for the second derivative.